In these videos, I'm going to be documenting myself making a simple voxel engine with cellular automata and water flow and sand falling. All right, let's get started. So first, before we get into anything, I'm going to explain kind of what the code is going to look like. If you're wondering what this app is, it's called eraser.io. If you just go to eraser.io, you can create an account with Google and log in. So in here, I'm just going to show you, before we go in Unity and create our classes, I'm going to create these boxes, and each of these boxes is just going to represent a class. So the first thing we're going to do when we open up Unity is we're going to create a voxel store class. And a voxel store is going to store essentially an array of voxels. So it's going to be basically a byte array of voxels, right? And then we're also going to create a voxel renderer. And this voxel renderer is going to receive the voxels, or the byte array, and it's going to output a mesh and add it to a game object, right? But in order for this to work, what we're actually going to do is we're going to pass a reference. So let me just go ahead in here and say this is going to be the voxel store, right? This is going to be the voxel store class. And it's going to have a reference to the voxel renderer. And it's just going to be a renderer, right? Now the voxel renderer is going to have a method on it called render voxels, and it's going to take in that byte array of voxels, and it's going to return, so it's going to be a private, or no, a public mesh. Well, actually no, it's not going to be mesh, it's just going to be public void, and inside of here we're going to render the voxels per se. You can kind of think of it that way, right? And so we're just going to call this right here render voxels. So that's what we're going to be making in Unity, and then we're just going to call this voxel flow. All right, so let's go ahead and do that. All right, so make sure you have the Unity hub installed, and from there create a new project and select 3D URP. The Unity version I'm using is 2022, so I really hope you use a version like that or later, because it's really going to help you out. Because if you don't have the same version as me, you will probably hit a lot of problems. So make sure to install that, and then we can call our project voxels, or I'm just going to call mine voxels flow, because I'm going to be doing cellular automata with flowing water, hopefully. We'll see. And then go ahead and click create project, and I'll see you in there. Unity, we're just going to create a folder. I'm going to call this voxels. And then here we're going to create a script, like I said, voxel store. And then another script called voxel, oh, wait for it to load, voxel renderer. Okay. Then create a game object, and we're going to call that voxels. And let's just add both of these scripts onto that. Make sure the position is reset on that. And then you can just double click and we'll open it in Visual Studio. All right, so let's make that bigger so you guys can actually follow along. And here. And if you are not able to use Visual Studio, you can also use Visual Studio Code. That way it'll look consistent. I'll probably do that later. All right, so our voxel renderer, we're not going to do that now. We're just going to do a voxel store. Okay, so first in our voxel store, let's store a private byte array of voxels. And we're going to call that, we're going to create it actually right here, new byte array. And then we're also going to create a width and height for this. And actually, yeah, we're going to create for now we're going to do 2D. So we're going to create a flat world of voxels. So we're just going to do a width. So a public int width. No, actually, hold on one second. We're going to do this differently. So go back to Unity. We're going to create another script, and we're just going to call this voxel constants. Sure, let's do that. And then in there, we're going to create this as a public static class. It's not going to inherit from mono behavior. We're just going to store a bunch of variables that we'll use all over the place. So public int voxel resolution. So we're going to set that to 16. And public int public static read only int resolution. Okay, now make sure it's public, static, and read only, and that the class is also static. And now we can go into here, and we'll just get a voxel constants dot resolution, and then times voxel constants dot resolution, right? So for now, and actually, let me think about this. You know what? We're just gonna do it in 3D right off the bat. So all 3 axes. All right. We now have our voxels, and then we're going to create our private void start, and we're going to say voxel renderer, and actually we need the reference to that. So serialize field private voxel renderer. Okay. So we can just say voxel renderer dot render voxels, and now let's go and make that method. So open up the voxel renderer. We can create a public void render voxels, and it's going to take a byte array of voxels. And there we go. And I paused the video there, but you probably don't know it because I edited it out to figure out some things for you guys. What we're going to do is we're going to go into Unity again, and we're going to add another script. We're going to call it voxel utils. Now we can open this up. It's going to be also a public static class, and it's going to have a method from another project of mine called index3d, and this is just going to take in an XYZ and return the index of your the index into this integer, the index into the voxels. So the voxels is a 1D array, right? But we can store 3-dimensional data, a grid that's 3D, and just index it here. So I'm just going to change this a little bit. It's going to be voxel constants dot chunk resolution, voxel constants dot chunk height, and voxel constants dot chunk dot chunk resolution. All right, now we're going to add the height value to voxel constants. So public static read only int height is going to equal 32. I'm just going to make the height slightly bigger. And why is that not working? Public static read only int height. Okay, there we go. It's working. All right. And then make sure to pass in the voxels to the render voxels method that we just made. Okay, so we've got that working. Now it's time to fill the voxels array with actual data before we send it over to the render voxels method. do that, I'm going to download a library in here, and we're going to need it. It's called noise, fast noise light. So just type in fast noise light. Should show up. Fast noise light, fast portable noise library. It's by Auburn, and then you can just go here to C#, fastnoiselight.cs. Click on that file, and then let's just go ahead and download the raw file. I'm going to open that in Finder. Nope, that's not what I wanted to do. All right, so we've had the file here in my downloads. I'm going to go into Unity here in this project. Nope, wrong project. In here. And then you can just drag the file in. Before we do that, actually, go here, create a new folder. Let's call that noise. And then in here, we can just drag in our fast noise light. And once that is done, I'm just going to delete that. All right, cool. So we've got this here, fast noise light. All right, so let's go into our code again. And in our Voxel store, we're going to create a private void generate data. It really doesn't matter because we're going to delete this later. And then we're going to create a for loop. So for int x equals 0, x is less than voxel constants dot resolution x plus plus. All right, just going to copy that several times, and we'll call that y height and y, and then x, z and z. All right, so now we can do voxels, and we'll set our voxels. So we're just going to do if. Well, let's get the noise first. So let's create an instance of our fast noise light library for this. So fast noise noise. Just going to create a new fast noise light instance. Boom. And then here we can just say float height is going to equal noise.getNoise at the x and z. And this is going to return, if I hover over it, it's going to return -1 and 1. I don't know if you can see that, it's pretty small. So I'm going to convert that to divided by 2, which gives us now a range of -0.5 to 0.5, and then add 1. And now we have a number between the range of 0 and 1, which is perfect. Then we can go ahead and just multiply that by, let's say, half of the height. So also, one thing I forgot to edit here that I just noticed is in the voxels array, this needs to be height. So yeah, voxel constant's the height. There. Okay. Let's go ahead and do this. So we're going to do half the height, and that's just going to be there. All right. Cool. So, and actually, yeah, let's do height, say -3. I don't want all the voxels going 32 height. And now let's set the voxel. So if y is less than the height, we can say the voxels, and we're going to say voxel utils dot get index 3D. We're going to pass in our x, y, and z right here, and that gives us the voxel in this one-dimensional array. We pass in a 3-dimensional position, and we are able to access the voxel in there. That's going to equal, if it's less than a height, it's going to equal 1, right? So let's just say 1 equals solid. Otherwise, it's going to equal 0, which is just air, basically. All right, now this is super simple. Generate data, and then just make sure to call it here. And we're done with the voxel store. So voxel store is going to call voxel render and render voxels. Render the voxels. If you don't realize, I edited the video again and went and did some stuff. So here's what we're going to do. We're going to create a new class called renderable. So private class renderable. And this is just going to hold a game object, and it's going to have a method that we're going to call public void set mesh. And it's just going to take a mesh. Boom. So in here, we're going to be able to set the mesh of the renderable. And then in the constructor, we're going to create public renderable, and we're going to take in a couple things. First, we're going to take in a mesh. So when you first create it, you can have a mesh. Now, create a couple private references. So private game object, as well as a private mesh renderer, a private mesh collider. Well, we're not going to need that yet. Let's just forget the mesh collider. Mesh renderer, private mesh filter. All right, and then also, just because we need to also add a material. All right, and then in here, we're gonna add a material, a serialize field, private material. All right. Render voxels. At the end, we're going to create a new renderable. I want to just pass in a mesh that we're going to create here. We're going to just call this mesh equals a new mesh. And for now, just pass that in as well as the material. All right. So let's add the code for this. So game object is going to equal a new game object. And I'm just referencing some old code that I created here for a much larger project. Also, we're going to need voxel utils.string ID. So I'm just going to, we'll do that in a second. But yeah. All right. So new game object. And then mesh render is going to equal actually game object dot add component mesh renderer, and then the mesh filter is going to equal game object dot add component mesh filter. All right, cool. Now I want to name this game object something nice, so we're just going to go in here and we're going to add this toString. Also, if you didn't realize, I have to get this aggressive inlining. This right here is just going to make it so that our index3D runs super fast, and you're just going to have to include system.runtime.compiler services. But yeah, don't worry about it. Let's see again, Vox render. Yeah, so just simple. This is totally unnecessary, but I'm just going to do it anyways. Public static string, and it's going to call it string ID. And it's going to take in an X. It's going to take in actually an int3 ID. And we'll be using these later, possibly if I get to world generation. And then for that, you're going to have to be using unity.mathematics. Okay, cool. Totally unnecessary, like I said, but basically we're just going to do a $string, and that lets us, the $sign before the string lets us input these curly brackets. So we're just going to say id.x underscore id.y underscore id.z. Totally unnecessary, but I'm going to be expanding this a lot, so we'll see. All right, so we're just going to voxel utils dot string ID, and we'll just create a new int3. and also using unity.mathematics. All right. Now, let's see. Yeah, that should be all. We've got the renderable and the mesh filter. All right, so in set mesh, we're just going to say mesh filter dot mesh is going to equal mesh. Boom. And then mesh render also needs to have its material set, so material equals material. Boom. We're done. Now all that's left is to actually create this mesh. So to do that, we're going to create another loop for, and we can actually just go here to our Voxel store and just copy this. So copy that and paste it into here. All right, so instead of this, we're gonna generate the mesh. So what I know, so let's see, we're gonna need a list. So a list of vector 3s, and that's gonna be, why is this? Okay, a list of vector 3, we're gonna call these vertices. It's gonna equal new list of vector 3, and later we'll change this if we want to from lists to native arrays and use the advanced mesh API, but that's later. All right, a list of integers, and we're just gonna call this triangles. That's gonna equal new list of integers, triangles. All right, so now we're also gonna need one more thing, a private void mesh quad. So this is just gonna create a single face for our render voxels. And this is where all the code is going to go. So this is also going to need to take in a list of vertices and a list of triangles, and we'll be adding to those lists. We'll also need, let me just check because I don't remember how I did this. Yeah. Oh, actually, well, let's just do it that way. Okay. Remove the mesh quad. We're not going to do that. We're just going to put it all inside of here. So let's create a vector 3 int, and we're going to call this the offset. This is going to offset our mesh. So each cube we add, well, let's just do it without the offset, and I'll explain it why we need it later. All right. All right. Let's see. Next thing I'm going to need is the voxel solid. So first, if voxel utils, and we're just going to go if voxels, right, the voxels we're getting at voxel utils dot get index 3d xyz is equal to 1, then we're going to mesh the voxel, right? If it's equal to 0, it's error. We don't need it. We don't need to mesh it. And this will all, I'm going to make it very modular, so updating the code is going to be very easy, hopefully. All right. Then what we're going to do is we're going to create a loop. So for int face equals 0, face is less than 6. And the reason for that is that a cube, just a 3D cube. If you see this, a cube has 6 sides. So 1, 2, 3, 1, 2, 3, 4, 5, 6. I mean, if you count the sides of a cube, it has 6 sides. All right. And then for each of these faces, we're going to generate a quad. And a quad, if you don't know what that is, quad is just not that kind of quad, mesh quad 3D. Wow, voxel. Well, let's just go here. Single quad. This is my course. It's outdated, but I am going to use it to reference this. Single quad is going to be a square like this, and it's going to have a triangle, right? and that triangle is going to make up our quad of our mesh. I'm not going to explain it. If you want, you can go to this link. And this is pretty similar to what I'm going to be doing, but the code I'm going to be using is going to be from this lecture. And we're going to be using these. So these tables to build our cube. I'm not going to be copy and pasting from here though. I'm going to be copy pasting, and don't go to this link and use these because this is going to be different. I will leave a link in the description for you, but the code we're going to use is basically like this code. And for that, for us to make a quad mesh, we are going to need to create another class that's going to store the tables that'll make this super fast. So go into Voxels. Let's create another C# script. And like I said, this script is going to be the Voxel table script. I will provide a link in the description to it. And there you go. And it's going to be a static class mono behavior. Cool. And this is mainly to document what I'm doing, but you are welcome to follow along. All right, let's see. So each one of these is all 8 corners of a cube. If you just go to Google, this is going to be all 8 corners of a cube, right? Those are stored here. And we're going to need those to build the mesh for the cube. I'm not going to explain it here, but I am going to be making a course on how to make this eventually, I plan. But like I said, this is mainly to document. All right, here we go. Quad vertices. Cool. All right. So to do this, we're going to say vertices dot add. We're going to add voxel tables dot vertices, and like I said, all 8 vertices for each side of a cube, right? But there is 6 sides to a cube, so we need to know which one of these vertices we need to make this quad, and we're gonna have 4 vertices to make that quad. So 4 vertices to make the square on one side of the cube. So how do we know which vertices those are? Well, thankfully, in the voxel tables, we have this quad vertices index. And in here, it has the numbers that we need to access of each one of these. So 4 numbers for each 4 different vertices that's going to take to make the quad. So this is going to be the right quad. So pretty simple. We just do voxel tables dot quad vertex index. And the first number is going to be the face. So right, left, up, down, front, back. So this is right, left, up, down, front, back. So the first index is just going to be face. And we have this right here. So we'll just do face. And then the second number is just which vertex to access in here. And we'll just do 0, 1, 2, 3, right? You get the idea. What am I doing here? There we go. All right, so we can just copy this into all of these. Just 1, 2, 3, and that will literally, that's it. That's all the code right here in this loop is going to build us an entire cube. Super simple. All right, and then finally we just need the triangles. So the triangles tell us take these vertices and build 2 triangles to make up a quad. And if you want an explanation for just how triangles work, but not how the code in this video is working, you're welcome to check out this website that I have where I explain that. It's pretty simple. All right. Let me just go into here. Triangles have a specific order. But yeah, I'm just going to add that. And then we also need to keep track. Which vertex are we at right now? So for that, I'm just going to do private int vertex index is going to equal 0. Private int. Yeah, slight interruption. All right, so back to what we were doing. Triangle index is going to equal 0. All right, I'm not sure what happened here. Cannot have private inside of pretty simple mistake, but yeah, cannot have private instead of a function, obviously. All right, so vertex index and triangle index. So vertex index basically tells us where in the vertices, because this is going to be a very large list, and we need to know we might need to know at some point where we are. So we're just going to do here vertex index plus equals 4 because we added 4 vertices, and then triangle index is going to plus equal 6 because we added 6 triangles, and then the triangles are going to reference the vertices, the 4 vertices in this area, so we just need to offset by the vertices, the group of 4 vertices that we are currently adding. So vertex index helps with that, and then this orders a specific number, but you don't really need to worry about it. All right, cool. So with this code, we have generated our mesh. Now what we can do is just go mesh.set vertices, and we'll just pass in the vertices, and there you go. And mesh.set triangles, we can say triangles, and just with that information, it does not like that for some reason. Oh, that's right, 0. Okay, that 0 at the end is submeshes. We're not going to worry about that. Just put 0. All right, so the other thing is we're going to need to generate normals. So mesh dot recalculate normals, and we'll also need to do mesh dot recalculate bounds. Pretty simple. Bounds tells Unity whether or not it should render the thing, so it'll be a big box. You don't see it, but it's a big box around the mesh, and as soon as that box is no longer within the camera's field of view, it'll stop rendering it. And so we can just we're calculating the bounds here. Don't worry about it too much. And then normals are telling us which side of the triangle to render. If you've ever looked at a mesh, let me just show you here. So if you have the normals facing towards you, you will see the triangle, right, of a mesh. But if the normals are facing away, you will not see it. That's not really what normals are for. Normals are for lighting, and the way a normal works is it just points straight up from the surface. Anyway, with that, we have our mesh. I mean, it's really not that difficult. Yeah, renderable. So yeah, one other thing we're gonna need to do is, since we're passing in the mesh here, so mesh filter dot mesh is gonna equal the mesh. For some reason I didn't do that. Set mesh is just gonna let us update the mesh later. But yeah, so mesh filter dot mesh, and then here the renderable, we create a new game object, and we give it a name, add the components. Everything should be set up. So now we can go back into Unity, and I am using the universal render pipeline. So if you're not, it'll still work. Some things might be different, but I highly recommend that you make sure this project is in the universal render pipeline. All right, so if you go here, we're going to need a reference to our Voxel renderer in our Voxel store, and we're going to create another folder for art, create a material, call this the default material, and we're just going to slap that in there. And hopefully if I click play, we should see a cube, and we do. All right, now that's one cube. Why are we only seeing one cube instead of a whole mesh? Why are we not seeing, I mean, not a whole mesh, but a whole chunk, a whole like Minecraft chunk? Well, in here, I mentioned that I was going to skip this step in order to teach you why it was important. So vector 3, we're going to create a vector 3 and we're going to offset. So for every block that we create, cube, add cube mesh, right? So for every block in here that we're adding them all at the exact same spot. So we need to offset them. We need to offset them so that they move here. Basically, we give an X, Y, and Z position, but we're never adding the X, Y, and Z position to the vertex. So we're going to do that now. Create a new vector 3, X, Y, Z. And then basically, you just need to add offset, add offset, add offset, and add offset. Whoops. Do that inside of that. Inside of the add function for the vertices, or the add method. And now that we've done that, you can click play, and voila, we have a Minecraft chunk, except it's missing half of itself now. This is also an issue that we will solve in the next video, but we'll solve it right now really quickly, and I'll explain why this is happening. The reason it's happening is you can only have so much data in a single mesh. Like, you cannot have 12 gigabyte meshes. It's just going to crash your computer. So there's a limit, and our mesh is just too big. So we can solve this for now by going into the voxel constants, changing the resolution to 8. And this is really just the width and depth. So in the resolution controls the Z and X direction size of the mesh, and then the height obviously is the height. So we'll just change that to 16. Now that the mesh, or the Minecraft chunk, you could call it, is going to be smaller, we should see the whole thing, and we do. It's really small, but you can see obviously there's like cubes, and it makes up a chunk. And yeah, that's all for now.